Hello everyone, we are students from C2134 Fluid Mechanics, and today we are excited to share some insight about an important phenomenon in fluid dynamics, the water hammer effect. Start, let's take a look at the common type of pipe found here in Singapore. Inside these pipes, water flow and the nature of this flow can vary. It can either be laminar or turbulent. The flow characteristics depend on factors like velocity, pipe diameter, and the viscosity of the fluid. So, what's the difference between laminar and turbulent flow? In laminar flow, water moves in parallel layers smoothly and without mixing. You can think of it like cars moving in orderly lanes on a clear highway, stable, predictable, and usually occurring at a lower velocity. In contrast, turbulent flow is irregular and chaotic, with constant fluctuation in both speed and direction. It's as if traffic were congested, with cars waving in and out unpredictably. Turbulent flow also usually occurs at higher velocity compared to laminar flow. However, it's important to note that laminar and turbulent flow represent an ideal state of steady flow. In real-life situations, however, fluid flow is often disrupted, especially when the valves are open and close quickly.
Now let us learn about applications of water hammer in real life. In a residential setting, water hammer is often experienced in washing machines and faucets. In an industrial setting, such as in power plants and manufacturing units, water hammer can occur in large-scale piping systems where the high velocity and mass of flowing fluids can lead to significant hydraulic shocks when stopped abruptly.
So, how does it work? Firstly, when a valve is open, it allows water to pass through freely. If the valve is quickly closed or if there's a sudden change in flow, the moving water is forced to stop or reverse abruptly. When this happens, the momentum of the moving water has nowhere to go, which creates a high pressure wave. The high pressure wave travels through the water and along the walls of the pipe, putting stress on the pipe.
I will now be talking about the dangers of water hammer, one of which is the sudden closure of valve resulting in fluid to change directions repeatedly, resulting in pipeline noise and vibration. Water hammer also results in leaks at pipe fittings, failure of other pipeline components, and damage to the product being processed. I'll now be demonstrating the severe impact of the water hammer. Take the case of 100 gallons of water flowing in a 5 cm pipe at a velocity of 3 meters per second. When this flow is rapidly brought to a halt by a fast-closing valve, the force generated is equivalent to that of an 835-pound hammer slamming into a barrier. However, what happens if the water hammer occurs at massive industrial systems? Obviously, the impacts are going to be large-scale. Let's talk about the 1981 water hammer incident at the Colorado River Aqueduct, where a significant water hammer event occurred. The Colorado River Aqueduct is a crucial system that transports water from the Colorado River to regions in Southern California. In 1981, the sudden closure of a valve caused a massive pressure surge, resulting in pipe ruptures and substantial water loss. This disrupted water supply for millions of people and caused extensive infrastructure damage.
Okay, let's dive into the equations behind the water hammer problem. The first equation, known as the Joukowski equation, calculates the pressure surge caused by a sudden change in flow velocity. And the next formula, the Cook-Book-White equation, helps us to determine the friction factor in the pipe. And the third formula calculates the frictional head loss along the pipe, which is a result of the internal resistance. Then let's take a look at the Python simulation of the water hammer effect. In this visualization, we can see how a sudden valve closure creates a pressure that propagates through the pipe.
Now let us talk about the solutions to the water hammer, one of which will be to install air chambers or water hammer arresters to help reduce the impact of shock waves. Next will be to have proper system design and programming where pipe modifications have to be made. Next will be to have proper system training where operators are taught on how to properly open or close a valve. That being said, that sums up our video on the water hammer. Thank you for your attention.